Good morning, students. Jai Swaminarayan. Welcome to our video lecture of chapter 8. Students, due to some uneven circumstances, I am recording this lecture and uploading the lecture. And in this lecture, we will discuss the topic of types of functions. In this lecture, students, we are going to discuss the topic of types of functions. So all of you concentrate and try to understand. And the advantage of this recorded lecture is that students, you can see this lecture repeatedly till you are clear with the theoretical base. Now students, as such, we have three types of functions. First is one-one function. Second is many-one function. And third is constant function. Technically speaking, we have more types of functions. But students, the type of functions which are included in your syllabus are these three types of functions. Once again, let us revise, students, what is a function. Suppose A and B are any two non-empty sets. Suppose A and B are any two non-empty sets. If for each and every element of A we have only one element of set B, or for each and every element of A there is association with only one element of B, then such a relation, association or correspondence is defined as a function from A to B. Set A is domain and set B is codomain. This was the definition of function. Once again, suppose A and B are any two non-empty set. If each and every element of set A is related to one and only one element of set B, then such a relation, association or correspondence is defined as a function from A to B. Set A is defined as domain and set B is defined as codomain. Now, students, basically there are three types of functions. The first type is one-one, second type is many-one function, and students, the third type is a constant function. Now students, first type of function we are going to understand, and that is students one-one function. All of you pay attention, students. This here is good that this is a recorded lecture. The advantage of this recorded lecture, I told you, is that students, you can refer this theories again and again till you have understood. Now, what is one-one function? Say f is a function defined from n to n. Domain is set of natural numbers, and codomain is also, students, set of natural numbers. Say f is any function defined from n to n, and the functional rule is x plus 5. Now, by this time, all of you know what is the definition of domain, all of you know what is the definition of codomain, and all of you know what is the definition of range. Now, students, domain is n. N's set of natural numbers starts from 1. So f of 1 will be 1 plus 5, 6. F of 2 will be 2 plus 5, 7. F of 3 will be 3 plus 5, 8, and onwards. So image of 1 is 6, image of 2 is 7, image of 3 is 8, image of 4 will be 9. So here each and every element of domain has a unique image in codomain. No two elements of domain have the same image, then such a function, students, is called one function. If I draw the set diagram, then that set diagram will be like this, students. Pay attention. This is domain. Say this is codomain. There are infinite sets in domain and codomain. 1, 2, 3, 4, 5, and onwards. Same way here also we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, and onwards. Codomain. Recall the definitions of domain and codomain. What is domain? The set of elements for which images are obtained is called domain. What is codomain? A set consisting of all the images and more elements is called codomain. And what is range? Then definitely, students, I can say set of images of elements of domain is called range. So 1 is associated with 6, 2 is associated with 7, 3 with 8, 4 with 9, and onwards. So what is the definition of one function? Students, all of you pay attention. I am going exactly as per textbook, but in simpler ways. For a function f, where each and every element of domain has a unique image in codomain, means no two elements of domain have same image, then such a function, students, is called one function. Now, students, pay attention. Definitions are to be written as given in textbook. So I am reading the definition given in textbook. Suppose f is a function defined from a to b. So suppose this set is a and this set is b. Here I have taken from n to n. In general, say f is a function defined from a to b. So a is domain and b is codomain. For any two different elements of domain A, their images or functional values are different, then such a function is called one. For any two elements of domain, say 1 and 2 are any two elements of this domain as per our example, their images are also called functional values. So if their images or functional values are same, then it is not one function. But if their images or functional values are different or unique, then such a function is called one function. So once again, suppose f is a function defined from a to b. For any two elements of domain, if their images or functional values are different, then such a function is called, students, a one function. Here suppose 1 and 2 are elements of domain, their images or functional values are different, so this function is called one function. Now students, they have defined one function in mathematical notation. This is very important. Say, what is the mathematical notation of one function? Students, all of you, please concentrate. We are understanding mathematical notation of one function. Now, students, let us go as per the textbook. F is a function defined from a to b. So immediately the first step, a is domain. and B is open. So any two elements A1 and A2 of domain, A1 and A2 belongs to A. For example, A1 is 1 and A2 is 2. So for any two elements of domain, that is symbolically written as A1 and A2 belongs to A. F of A1 not equal to F of A2, then F is 1 function. Check. Suppose A1 is 1 and A2 is 2. F of A1 means F of 1 is 6 and F of A2 means F of A2 is 7. Definitely 6 not equal to 7. So this function is 1 function. This is mathematical notation or mathematical definition of 1 function. Once again, F is a function defined from A to B. A1 and A2 are any two elements of domain. If F of A1 means image of A1 not equal to image of A2, then F is 1 function. This is a diagram of 1 function, students, which I have shown. So, in nutshell, if I want to define 1 function, now all of you please concentrate. F is a function defined from domain A to codomain B. For any two elements of domain, if their images or functional values are different, then such a function, students, is called 1 function. I have already stated an example. This is arrow diagram and this is mathematical notation or mathematical definition of 1 function, students. So I hope this is crystal clear. All of you would have perfectly understood. Once again, the mathematical notation is like this. F is a function defined from A to B. A1 and A2 are any two distinct elements of domain. Their images are also called functional values. Remember, images are also called functional values. Images are also called functional values. Now, students, with this example, with this concept, I hope that all of you have clearly understood the definition of 1 function. You can note down this example also while you are referring this here. Okay, students. The second type of function is many one. Students, the second type of function which we are going to discuss in detail is many one function. Students, let us write the title. The second type of function is many one function. Okay, students, concentrate and pay attention. Again, I am taking an example. Say f is a function defined from z to z. This is domain and this is codomain. Z is equal to set of integers. This much I suppose all of you know. And if you don't know, then try to understand, students, what is Z? Z is nothing but set of integers. Integers can be either positive or negative, including 0. So this set is an infinite set. So I can write this as minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5 to infinity. Now, the functional rule is say f of x is equal to x squared plus 1. Now, I have taken the examples where domain and codomain are infinite sets. You need not worry. Domain can have 10 elements, 100 elements, or 1000 elements. So you uncountable number of elements. So there is no restriction to this, that the domain or codomain must be a countable set or it must be an infinite set. Both is allowed. Now students, pay attention. F of minus 1, because integers are negative, positive, including 0. So this is minus 1 square plus 1, which is 1 plus 1, 2. And if I find functional value at 1 or image of 1, 1 square plus 1, so 1 plus 1 is equal to 2. So minus 1 and 1 are different elements of domain, but their images or functional values turns out to be same. I repeat, minus 1 and 1 are different elements of domain, but their images turns out to be same. So I write like this, minus 1 is definitely not equal to 1, but f of minus 1 is same as f of 1. So what is the definition of many one function? Students, pay attention. What is the definition of many one function? Let f be a function defined from domain A to codomain B. This is the symbol or mathematical notation to write a function. Suppose, students, f is a function which is defined from domain A to codomain B. For any two distinct elements of domain, if their images or functional values are same, minus 1 and 1 are distinct elements of domain Z, their images 2 and 2 are same. So for any two distinct elements of domain, if their images are same, then such a function is called many one. And if their images are not same, means different, then such a function is called one function. Clear, students? All of you understood? Once again, suppose f is a function defined from A to B. You concentrate here, students. For any two distinct elements of domain, means minus 1 and 1 are distinct elements of domain Z. If their images or functional values, images are 2. If their images or functional values are same, then such a function is called many. And alternatively, if their images or functional values are different, then such a function is called one function. So what will be the mathematical notation for function which is many one? Mathematical notation or mathematical definition. Suppose f is a function defined from A to B. A1 and A2 are any two distinct elements of domain. And if f of A1 equal to f of A2, then f is many one function. This is called, students, the mathematical definition of function. A1 and A2 belongs to A, and definitely A1 and A2 are not equal. Means A1 and A2 are distinct elements. Take minus 1 and 1 are not equal. So, students, remember in shortcut, if images are distinct, for distinct elements, such a function is one. And for distinct elements, if images are same, then such a function is many one function, students. This is what we have to concentrate on. This we have to, students, perfectly understand. So textbook definition goes like this. Suppose f is a function defined from A to B, and for any two different elements of domain A, their images images of function values are same, then students such a function is called many-one function. If I draw the arrow diagram, it would be like this. So this is set A. So this is set B. So these are two distinct elements, A1 and A2. Then images are same. F of A1 is equal to F of A2. For A3, the images is F of A3 like that. So this is arrow diagram. You can draw students arrow diagram as given in text as it is given for limited number of elements. You can draw students as given in textbook as is given for limited number of elements. Now students, the last definition, it is the constant function. All of you pay attention. The last type of function which is there in your syllabus and defined. So students, all of you please pay attention. The last type of the function is a constant function. Now students, constant function. This is the third and the last type of function included in your syllabus. This is the third and the last type of function which is students included in your syllabus. Now see students, concentrate. Say f is a function defined from 1, 2, 3 to 5, 6, 7. Suppose and f of x is equal to 5. Functional rule is f of x is equal to 5. So your domain is set 1, 2, 3 and students your codomain is set 5, 6 and 7. Now recall the definitions of domain and codomain. The set of elements for which images are to be obtained is called domain of the function, and a set consisting of all images and more elements is called codomain. Now, so I start with 1. F of 1 will be 5 because there is no x on the right hand side which is to be replaced by 1. So image of 1 is 5. Image of 2 is also 5 and image of 3 is also 5. So all the three elements of domain 1, 2, 3 have same image in codomain which is 5. Such a function is called a constant function. So the definition goes like this. Suppose f is a function defined from a to b. A is domain, b is codomain. If each and every element of domain has same image in codomain, or if each and every element of domain has same image or functional value, then such a function is defined as a constant function. So once again, the definition as goes in textbook. Suppose f is a function defined from a to b. If each element of domain A has the same image or functional value, then such a function is called a constant function. Such a function is called a constant function. If I draw the arrow diagram as per example, say this is domain A and say this is codomain B. Domain is 1, 2, 3. Codomain is 5, 6, 7. 1 is associated with 5. 2 2 is also associated with 5 and 3 is also associated with 5, then such a function is called a constant function. I think students you will really enjoy this video lecture after a very long time. This lecture, we have uploaded a lecture after at least you can say 2 months, and this was, you can say, intentional, because you will have this lecture at your ease. You can repeat this lecture as many times you like. So, what is the definition, students, of a constant function? Please concentrate and try to understand. Suppose f is a function defined from domain A to codomain B. If each and every element of domain A has the same image or functional value, then such a function is called a constant function. The best example I have already given. So students, now the definitions of type of functions is clear. So we can go for the MCQs related to this particular topic. Now, exercise 8, section A. I think we have done the first 3 MCQs. I remember, students, we have done only first 3 MCQs of section A. Now let us go further and do the next 3 MCQs. What is the type of the function defined from A to B wherein 2 different values of domain, their functional values are same? Now just now I have revised. Once again I am revising these 2 definitions as per the MCQ. If 2 different elements of domain have different images or functional rules, such a function is one. And if 2 different elements of domain have same images or functional rule or value, not functional rule, sorry students. If 2 different elements of domain have same images or functional value, then such a function is one node. And if 2 different elements of domain have same images or functional values, then such a function is many. So when 2 different elements of domain have different images, then one node, and same images or functional values, then such a function is many. So as per the option in the 4th MCQ, students, the correct answer is many one function. This goes with the definition. This goes with the conceptual understanding, students. So once again, last time, for 2 different elements of domain, if their images or functional values are same, then according to definition, the function is many one. So 4th MCQ, the answer is option B, many one function. Students, the answer is option B, and that is many one function. Okay students, now MCQ 5. What is the type of function A to B where each value of domain has the same image in set B? MCQ 5. Each value of domain A has same image in set B, then such a function is called a constant function. Students, according to definition, let f be a function defined from A to B if every element of domain has same image or functional value, then such a function is called a constant function. So as per the option, students, the correct option is option C. Which of the following statement is true for a 1-1 function, students? For a 1-1 function, which of the following statement is true? Only for 2 values of the domain, their images should be different. No. For all the elements of domain, their images must be different. For any 2 values of domain, their images are same. No. The first was for only two values. No, for every distinct value, their images should be different. For any two different values of domain, their images are different. So the correct option is option C. So this words makes altogether a lot of difference. So which of the following statement is true for a one-one function? So MCQ 6, the correct option is option C. For any two different values of domain, their images are different. For any two unique values or different values of domain, their images are also different. So the correct option is C. Okay students, MCQ 7 is the sixth MCQ students. The correct option is C. Now MCQ 7. F is a function defined from z minus 0 to n. From domain 0 is removed and fx is equal to x square. And x belongs to domain z minus 0. Students, z minus 0 means from domain z, 0 is removed. Now whenever there is a square term, we have to be very careful. Square term always implies minimum because image of minus 1 is minus 1 square, which is 1, and image of 1 is also 1 square, which is 1. So for two different elements of domain which are minus 1 and 1, their images are 1, which is same. So this function is many 1 according to the correct option. It's according to the option, the correct option is D, many 1. The correct option is B, students, many 1. When for two distinct elements of domain, if their images are same, then as per the definition, the function is many 1. So minus 1 and 1 are two different elements of domain and their images are same, which is 1. So students, such a function according to definition is many 1. 8th MCQ, the concept students we have not done. Concept of 8th MCQ is not done, that we will do afterwards. So hereby I conclude students this lecture. Thank you students.